So, good evening everybody. Welcome back to HPCL virtual internship program. So, coming back, who's Jaya Swaroop, Lohit, Girish, and who's that person? Vinay, correct? Vinay, and whom I am missing? One more person is there, right? Huh? Who is the other guy? Narasimha. Hi Narasimha. Am I audible to you? Okay, very good. So actually I have already taken one session regarding that introduction part of FCC operation, monitoring, control and troubleshooting. Correct? So one that word file I have given to you guys. Have you gone through that? Swaroop, have you read it? Yes, Swaroop, tell please.
Yes, sir. I have read the process, but I have not understood the specification in the text.
Okay. So what happens in FCC? All those are basics process. Have you guys read, everyone?
Yes.
Okay, very good. So Lohit, can you just brief like within one or 2 minutes what happens actually in FCC and what do we do?
Sir, in FCC, the heavy crude oil converts into lighter fractions, sir, which are the useful ones. By using the fluidized catalytic cracking, we use fluidized catalytic cracking.
Okay, very good. Basically,
And it also has 3 sections: catalyst section, fractionation section, and gas separation section. That I read.
okay, very good. These are the things what you just now told. The purpose of FCC unit, as I said, basically we do the cracking of heavier molecules to get a valuable product. That basically reactions happens into the FCC unit. Basically, that reactions happen into the FCC reactor. In that, after the reaction, we get the mixture of components: valuable component, low valuable components, LPG, petrol, diesel, all this we get. So basically it goes to the 3 sections you told now. One RR reactor region, another is fractionator section, and the another one gas concentration unit. Yeah. So basically it goes to the fractionator column. In fractionator column, based on the boiling point, we separate the different components like large distillate product, large pressure distillator. In that CRN and LPG will come, like LPG and CRN, cracked and naphtha. Then coming to the fractionator, next cut we get it is LCO, light cycle oil. Then we get it HCO, heavy cycle oil. These are two basically diesel graded products. Then for maintaining the column temperature profile, we give a kind of pump around one reflux. Just basically it is a heat profile maintaining, CRO, we call it as a CRO, circulating oil. Basically we take a withdrawal, we recover the heat from that, again give it back into the column as a pump around, and we are giving pump around for maintaining the column profile. Now the last one what we get is CLO. That slurry, basically we part of that slurry we use it itself into the fractionator column, and rest after the cooling we get is a CLO, clarified oil, and we send it into the the tanks we will having fuel oil tanks in that sometimes we use that oil CLO like after as a fuel oil into our refinery heaters for burning purpose. Another time we sell it to the customers, and these oils basically used in the sometimes heavy ships and all, they use this kind of oil. So this is just a brief I have told. In details I'll discuss today. So what just Lohit explained, there are 3 sections, one by one will go. One is RR section, so we'll discuss 3 topics. So these are the topics that I'm going to cover into this. Basically FCC introduction, which I have already explained. Then crude fractionation, that also I have told you in last session. Then different types of crude, FCC configuration in refinery, FCC process description, then FCC process flow diagram, FCC chemistry, FCC what are the catalysts that we are using into the FCC. Then what are the contaminants that can basically deactivate the catalyst, those kind of contaminants also will discuss. We get into the feed. Then FCC additives, what are the additives we are using in FCC for the maximizing the conversion and the deactivation of catalyst and all. Then at last we'll discuss FCC operation and the monitoring. Okay. So as I said, what is FCC is basically fluid catalytic cracking. So the fluid catalytic cracking process converts heavy crude oil into lighter, more valuable hydrocarbon like crude and naphtha, diesel, LPG. So as I tell, this is the FCC unit. We get a feedstock. You might be able to see. This is the feedstocks. We get VGO, CGO, DAO, hydrocracker bottom. In the VR refinery, that hydrocracker is not there. In generic process, I have written it here. So normally, basically, you can assume that basically heavy stocks we process into the FCC, and we get these are the typical products that we get from the FCC unit. Dry gas, LPG, that is then light cracked and naphtha, heavy cracked and naphtha. Basically, this is all cracked and naphtha. You can say this cracked and naphtha basically petrol grade material. Basically, it's a motor spirit. Once it is treated in the FCC and ST, we can use this product as a petrol. Then light cycle oil, CL, or heavy cycle oil or CLO. So is it clear till now?
Yes, sir.
Okay, very good. Now, so crude fractionation, like reason being why I kept this diagram, that you must understand where actually FCC lies, what is the role of FCC. See, crude we call as a crude unit, basically we call it as a mother plant into the refinery. Basically, crude unit is basically itself, after processing of crude, it gives different cups, different kind of products. Later on it goes to the secondary unit and the treatment unit for further processing before we get the final product. So as crude oil comes, you might be knowing when it comes, it goes to the desalter, basically removal of salts and all. We give mixing with the water, we form an emulsion, we apply almost 20,000 kilovolt electricity on the desalter, and based on that potential difference it gets separated. Then crude oil finally, then from that goes to the preheat exchanges, we call in CDU. Preheat trains will be here. Before that this crude goes into the heater, it goes to the preheat trains. From there, preheat trains basically whatever the draft we are getting from the column, the draft only pump around purpose, it goes to the preheat exchanges. And heat recovery, we are basically that crude we are heating, whatever the product we are withdrawing from the pump around we are withdrawing from the column, that heat basically is be recovered for the processing of heating the crude. After heating, it goes to the pre-flash drum. It's not mentioned here. In pre-flash drum, what happens? The crude goes, we give it a flashing so that whatever the lighter component will be there now, we don't want to boil because it will increase the heater load duty. So it will goes back to the column, correct? So rest all goes into the heater. From heater we heat it to the feed temperature. After that we send it to the atmospheric distillation column. From that we derive different products. As I said during the introduction part, LPG we get it from the top, part of some gas also we get, and then we get a SRN, straight run naphtha. Then after that from second withdrawal we get one top profile. This is a top pump round, but here we don't get any product, just for maintaining the column profile we give it. Then B withdrawal is there, heavy naphtha withdrawal is there. Then heavy naphtha withdrawal, basically here pump round also will be there. Column profile you cannot maintain if you don't give a pump round, because what is distillation column? Basically distillation column is itself what we call subsequent we call a vaporization or reboiling we give, and subsequent cooling we give, so that we maintain a column temperature profile, a gradient, temperature gradient we maintain throughout the column. That temperature gradient, temperature differences, column profile is maintained based on the pump rounds what we are giving. Now heavy naphtha we are withdrawing, then kerosene, then diesel, then atmospheric gas oil, then bottom product atmospheric residue basically goes to the vacuum meter. From vacuum meter it goes to the vacuum column. From there we'll get some gases will be there, then LVGO we get, and HVGO. LVGO basically sometimes directly used in the diesel as a part of diesel once it is treated into the hydrotreaters, diesel hydrotreaters. Then HVGO some FCC process after treating it to the hydrotreater, then it comes to the FCC, or most of the FCCs basically directly process HVGO to the FCC unit. So this is what HVGO heavy product we get into the FCC unit, and we do the cracking reactions into the RR reactor region. Then bottom is a vacuum residue, basically sometimes it go to VV unit for further processing, further treatment. So this is what we actually get. HVGO we can say as this is the product, this is the feed we use into the FCC unit. Is it clear as of now, the basics?
Yes, sir.
Any doubt? So I'm trying to reconnect you people from the basics, like how crude comes and where we exist in the refinery, like refinery, where does that FCC unit exist? Are you able to connect that link?
Yes, sir. Yes, sir.
If you guys get any doubt now, you can ask, no problem. Okay, anyway, I told you now, this is the normal FCC configuration, what I have explained just. Then there are different types of crude. See, anything any unit is there now. What we are going to process, we must understand the type of crude we are going to process. What type of crude our unit can handle. That can be heavy crude, then medium type of crude, there can be light crude. So heavy crude means basically having the high RCR, basically carbon content and sulfur content will be more in 90% of types of heavy crude. So like Arab high, Arab mix, Basra light, Arab light, Iran high, Murban. These are the crudes having high sulfur content, and thereby they will be having high carbons also. So basically FCC unit we prefer always to process the heavy crude, or middle lighters we normally we don't process much. We process, but we prefer to process basically this heavy crudes. So then the medium crude, Mumbai high, Boni light, Rawa, Reliance, Champion, these are the light crudes. So if you don't understand how much sulfur is there or carbon is there, when you process, what happens in the reactor, when regeneration happens, so that if heavy crudes are there, then along with the catalyst, that process I'll explain later, more carbon will come into the regenerator. Then at that condition, when you burn, the regen temperature, basically in regen we don't give any fuel for the burning. Whatever the catalyst participate into the reaction, on that some carbon will be deposited, it will be temporarily deactivated, it comes back into the regenerator where we supply air and we are burning off. So maintaining the regen temperature around 700 to between 700 to 730 degrees Celsius. So basically we burn off the catalyst into the regeneration, we make the catalyst as a fresh catalyst, that fresh catalyst again goes back to the reactor. So this cycle goes on. This is how we establish and see, in the reactor, how temperature we are maintaining, the temperature we are maintaining around between 500 to 530 degrees Celsius. So we give a set value to the reactor, we want 510 degrees Celsius. So that our EOP model, our operation is based on the slide valve. So basically we give set value some 510 based on that slide valve, RCSB we call it. Regen catalyst slide valve, that will open, will take the amount of catalyst till that temperature reaches to 510 degrees Celsius. So it will be opening will be some 35 to 40%. Accordingly, catalyst will come. Now into the reactor, how we maintaining the reactor level? In reactor also we maintain the catalyst level. That level we maintain around 40 to 45%, the EOP model. So that basically that SCSB means spent catalyst slide valve. That basically being controlled as a reactor level. So we give a set value to the reactor level. We want 40% level or 45% level. Rest all whatever level will be there, you have to transfer it to the region. So when level goes to above 45, you might have read about the controlling. PDC you have guys over for you guys, process dynamics and control subject.
Yes, sir.
Auto cascade, all those things you have guys read.
But for us, cascades are not very relevant, sir.
What happened?
Just we heard about the names about cascade control and all, but we didn't go on deep, sir.
Okay.
It's not in our syllabus.
Okay, what you guys do, like after the session is over, go through the read about them, because once I'll explain the details, the problem that you will not be able to reconnect. See, if you are not knowing the basics, how much I'll tell now, you cannot have a grip of that. Okay, you will have some idea, I'll explain. If you are having problem in getting that auto cascade, that also I can explain. But it will take a lot of time. The completion of this session itself will take a lot of time. Okay, but you guys read, I'm coming back to the topic. So, spent catalyst slide wall, basically we maintain a label, whatever the excess catalyst is there, slide wall will open and the spent catalyst go to the region. So on spent catalyst, carbon will be there. So this cycle keep going on. So this is how basically RR profile we are maintaining, reactor and region, correct? Basically so many parameters are there in details. If I'll go the operation, how RR we are operating, I'll explain. Okay, so FCC process description. So in FCC, there are basically these four sections are there. Are basically the feed preheat section. We take into the consideration of RR only. So here I kept as the 4 section: feed preheat section, catalyst section, that is RR, fractionator section, gas concentration section. So coming back to the feed section. So this is the small process flow diagram. I have mentioned it here. Can you guys see it? Is it visible?
Yes.
Yes.
Now is it visible?
Yes, sir.
Okay. So this basically feed. There are 2 types of feed we get into the FCC. One we call as the cold feed, that we get it from the tank, and another one we get a hot feed, that what we told you in CDU2, like CDU unit, that SVGO, those we take into the feed surge drum. With hot feed only we cannot operate, because there is a pumps and all, they'll cavitate at the higher temperature, they may not be designed. So cold feed, basically what is cold feed? Whatever the hot feed we are not getting from the CDUs, HVGO, they cool it through the cooler and they send it to the their tanks. So from the tank we get it, that we call as a cold feed. And the hot feed, directly what we take from the, without cooling from the units directly, is called a hot feed. So that temperature we get around, that hot feed temperature we get around 200 degrees Celsius and cold feed around some 70. So overall the temperature we maintain between the 100. We can run the unit with the cold feed, but hot feed it is very difficult for us to maintain, like sustain. So as a blend we operate. So hot feed we take and cold feed we take. Feed temperature we maintain between 100 to 155 degrees Celsius we can operate. So that 150 degrees Celsius temperature go to the feed preheat exchangers. Here I have not mentioned. Before feed, one preheat exchangers will be there. Through that it will go. After that it goes to that feed preheat exchanger. Basically whatever the slurry bottom we get it, this bottom through the slurry pump we get it and we route it to through the preheat exchangers. Okay, so we heat from the hot that hot process we are taking from the slurry, and feed we are making it to get heated. So feed once heated, it goes to some 150 degrees 160 degrees Celsius. After that heater will be there. Through the heater we heat it. We maintain the ROT. Basically heater we maintain, we give a set value here, some ROT between 270 to 285 degrees Celsius, 275 degrees Celsius. It goes from, after heating, it goes to the reactor. Now I told you how we are maintaining the reactor. See, that catalytic, that reaction it is happening, it is an endothermic reaction, correct? Anyone aware at what temperature the reaction occurs actually in FCC? How much?
Decreases. What will
Not for actually above 500 basically we prefer. 510, 510, 505, 530 degrees Celsius like that. Okay. So because below that, the cracking reactions very problematic. In fact, we have been given interlocks. If the temperature goes below some 455, 450 degrees Celsius, unit shutdown has to be taken care. We cannot process that feed into the reactor. So that kind of like normally that unit won't run based on the process flow diagram and all. There will be the interlocks will be there, safety guards. So many safety guards will be there. As a person, as a DCS, when you are sitting under the DCS, if you ever get opportunity to operate that, you will realize how much criticality is there. So lot of interlocks will be there. If you deviate any parameter, automatically shutdown it will happen. So and in fact, when you are sitting, you itself will be started taking actions and all as per the procedure and all. So the temperature around 505 degrees Celsius or 510 degrees Celsius be maintained. But the feed temperature, how much we are getting? 275, correct? But we want 500 degrees Celsius, 510 degrees Celsius temperature here. How will maintain? Okay, I'll explain this into the next half an hour session. Can you guys make another Zoom link? After 10 minutes you make, okay?